Hello class, this is a continuation on the transformations of log functions. In this video, we'll be tackling these two examples. So here we go. So in this example, I hope by now we are familiar with what the parent graph of what log base 2 or any base for that matter would be. So our parent graph here is log base 2 of x. And I've drawn here the different inputs and the outputs of what might happen. So for example, if we put x equaling 1, so we're ignoring the to the power of 2 for now, log of 1, no matter the base, I hope you understand now, is going to be 0. In this case here, when we put x is 2, so log base 2 of 2 is 1. And as you've seen before, this is 2 to the power of 1 equaling 2, so that is true. 4 being x is log base 2 of 4 equaling 2. That's the output. And this is true because the base, 2 to the power of 2, is indeed 4. So I've drawn here the parent graph of log base 2 of x. In order for us to understand what this square does, we must first understand log laws. Since this is x to the power of 2, we can simplify this expression as 2 log base 2 of x. So since we are multiplying the outputs of log base 2 of x by 2, let's take a look at what this would look like for each of these points here. So for example, if we were to put log base 2 of 1 into here, so 1, this would equal 0, and we would then multiply it by 2. So this point doesn't change. But now when we put x equals 2 into here, log base 2 of 2, well, that becomes 1, to which we are now multiplying this by 2. So this 2 comma 1 is now going to become 2 comma 2. Likewise with x equals 4. So when we put x equals 4 into here, normally this becomes 2. So then now we're going to multiply it by 2. So the output of this is going to be 4. So this becomes 4 comma 4. So instead of 4 comma 2, it becomes 4 comma 4. Hope from here you can start seeing what is going to happen. Likewise with this one, when we input x equals 8 into log base 2 of 8, that becomes 3, which we multiply by 2. So this 3, this output of 3, becomes 6, 4, 5, and 6. So this point becomes 6. So as you can see from here, it's actually moved, or you could say it's been stretched up. Everything's been doubled up. Likewise with here, this would also then, this point here, just to really get your minds going, let's say that point is x equals half. 2 log base 2 of half. You can check with the change of base, but this is like asking 2 to the power of something giving us half. I hope you can see that that something is negative 1. But negative 1, that output, so all of this becomes negative 1, to which we multiply this by the coefficient here of 2. So negative 1 becomes negative 2. So that next point goes down like so. So this is actually stretched outwards in the negative as well. Okay, so let's erase all of these points. This is our new, or compared to the original. The original is in gray, and the transformed function is shown here in blue. All right, so let's move on to the next. As you can see, this is near identical, and I've already drawn here what that would look like. So when we input e to the power of 1, this is log base e of e. Well, since these cancel, we're just left with 1. Likewise with e squared, log base e of e squared. Well, that will give us 2. And as I've shown you here, these are approximately to scale. E to the power of 1 is about 2.7. E to the power of 2, you can check your calculators, is about 7.3. So once again, because we're going to use log laws before we transform this, the 2, or whatever power it is really, moves to the front, and this becomes 2 ln of x. And so e, with an output of 1, is now going to become an output of 2. So this point has been moved up till 2. E squared, this point here, has been doubled to an output of 4. Oops. And with the scale of this graph that we have, there's not much more we can go from here. Oh, and e of 1 is always going to be 0. But as you can see, it's been stretched outwards, like it's been moved away from the original. Likewise with this point here, it would be moved further down. It's being stretched away like so. Right, so I hope that gave you an insight into just this first transformation. So don't forget that we can take the power and move it to the front by the use of log laws. Okay, so I hope to see you in the next video, and best of luck.